We've all been there, whether you're a first-year student or just learning on your own. You open that gross anatomy book for the first time.
Oh, yeah.
And the sheer volume of it, all the structures, the layers, the, spatial relationships, it feels immediately overwhelming.
It is. It's like being dropped into a massive, complex city you've never visited before, with no map.
Exactly. A highly engineered city.
That feeling of being lost in the detail is pretty universal, which is why the approach a foundational text takes is so vital. Today we're doing a deep dive into the strategy and philosophy of the Color Atlas of Anatomy, 7th edition.
By Rowan, Yokochi, and Luchendrakel.
That's the one. And our goal for you is simple: to really synthesize the architecture of the human body as this atlas presents it, focusing on how it bridges that gap between textbook knowledge and, well, clinical reality.
And the value of this atlas, it starts with the medium itself, right? The authors are very clear that this is a photographic study of the human body. They really stress that photos of actual anatomical specimens are crucial because they convey, and I'm quoting here, the reality of the object with its proportions and spatial dimensions in a more exact and realistic manner.
Way more than any schematic drawing ever could.
Yeah.
Exactly. I mean, we're talking about 1,211 figures, and over 1,100 of those are in color.
Wow.
Plus 94 imaging scans, X-rays, CT, MRI. The visual truth is the #1 priority, and that really informs the entire philosophy of the book.
Okay, so let's unpack that philosophy. If the goal is making all this complexity digestible, how is the material actually sequenced?
The sequencing is deliberately efficient. Instead of just throwing you straight into a dissection of, say, the head or the thorax.
Which is what a lot of courses do.
Right. Instead, the authors integrate these really comprehensive systematic descriptions first. So you cover osteology, the bones, then arthrology for joints, and myology for muscles as general systems. You learn the architectural rules first.
And then you move into the regional chapter.
Then you move into the regions. It just makes perfect sense.
It does. It means the building materials and the basic construction rules before you start trying to assemble something as complex as, say, the knee joint.
And this focus on realism, it's driven by a very practical need. The authors point out a modern challenge in medical education.
Okay.
The universal lack of cadavers in many departments around the world. So these detailed, realistic photos give students immediate, high-fidelity orientation for when they finally do get to work with a specimen.
So there are no surprises with the color, the texture, the density of real structures.
Precisely.
I really appreciate how they handle the super complicated regions. Let's take the skull. It's this mosaic of more than 20 bones. Just reading a text description is almost impossible to visualize.
It's a nightmare. So what they do is use what you could call an additive visualization strategy.
Additive?
Yeah. Instead of just one big labeled diagram, the atlas shows you the skull's architecture through a series of figures that visually add one bone to the next. You literally build the structure piece by piece.
Oh, that's brilliant.
It is. It totally demystifies the spatial relationships between, the temporal bone and the sphenoid bone. It turns a dense description into a sequential visual lesson.
That leads us perfectly into the grand design, the big picture. Before any specific region, the atlas lays out 3 governing principles for the whole human organism. What are these foundational ideas?
These are basically the 3 pillars of our macroorganization, right from the general anatomy section. The first one is the principle of polarity.
Polarity, so that implies contrast,
Yeah.
right? How does that actually manifest in the body?
It's the formal and functional contrast between the 2 ends. You have the cranial pole, the head, which is mostly spherical. It houses the central nervous system, our consciousness, the major sensory organs.
The command center.
The command center. Then you have the caudal pole, the extremities, which are radially arranged and specialized for locomotion and fine manual activities.
So control versus action, I get it.
Exactly. Our upright posture specialized the lower limbs for bearing weight and moving, while the upper limbs, and especially our hands, were freed up to become these amazing instruments for manipulation.
And for expression.
And expression, yes.
So if polarity defines the ends of the body, what governs the middle? The trunk.
That's the second principle, the principle of segmentation. This is what dominates the trunk.
Okay.
Just think of it like a biological assembly line where certain structures are rhythmically repeated. You see it in the vertebrae of the spine, the paired ribs, the trunk muscles, the nerves branching out. It's a serial arrangement built for flexibility.
And the third principle is probably the one we all recognize most easily.
Oh, for sure. It's the principle of bilateral symmetry. Our body is largely divided by a mid-sagittal plane, splitting us into 2 mirror image sides.
So understanding those three rules, polarity, segmentation, and symmetry, that's the framework that makes all the thousands of details start to click.
It's the mental map you need before you explore the city.
Okay, so once we have the architectural principles, we need the language to navigate the space. Anatomical directions and planes. That's often the first big hurdle for students.
It is, and you have to master them. You need all three core planes to interpret any medical image, period.
Let's run through them.
Okay, first, the horizontal, axial, or transverse plane. That one divides the body into superior or cranial and inferior or caudal parts, top and bottom.
Got it.
Then you have the sagittal plane, which gives you left and right halves. The mid-sagittal plane is the one that goes right down the center.
Yeah, the last one.
And finally, the frontal or coronal plane. This divides the body into anterior or ventral and posterior or dorsal sections, front and back.
And with those planes, you need the directional terms to describe where everything is in relation to everything else.
Precisely. You have to internalize the three big pairs, cranial towards the head versus caudal towards the feet.
Right.
Anterior or ventral, the front side, versus posterior or dorsal, the back side. And then medial toward the midline versus lateral, away from the midline.
And the atlas really excels at connecting these abstract terms to what you see in the clinic.
Yes, immediately. When you look at an MRI scan of the knee, for instance, you can see how a sagittal cut slices right through the femur, the tibia, the kneecap, along that front-to-back line.
Whereas an axial MRI of the pelvis, you're cutting horizontally. You see the hip joints and muscles laid out like a cross-section on a table.
And understanding that relationship is how you bridge gross anatomy to diagnostic imaging. It's fundamental.
All right, let's move to the physical framework itself. The support system. Osteology.
The skeleton. The atlas divides it very logically into two main support units. First is the axial skeleton. That's the head and trunk, everything along that central axis, vertebrae, ribs, sternum.
And then the appendicular skeleton, which is everything that hangs off that axis.
Yeah.
Girdles and the four limbs. Clavicle, humerus, all the way down to the tiny phalanges in your hands and feet.
Let's use the femur as our main example for bone architecture. It's on page 8 in the atlas, and it's a great illustration. When you see a coronal section of the top end, you realize bone is not just a solid rock.
No, it's an incredible piece of engineering. You've got that dense outer layer, the compact bone, but inside, especially in the head of the femur, you see this spongy bone.
Or trabecular bone.
Right, arranged in this intricate lattice work.
And that lattice work is everything. It's internal scaffolding, basically. The bone tissue is organized along what they call trajectorial lines of stress.
So it's built to withstand specific forces.
Exactly. This design lets the bone be relatively light while maximizing its resistance to the compressive forces of your body weight and movement. It's a biological truss system.
The atlas also gives a great reminder that this structure changes as we grow. It shows the skeleton of a 5-year-old, and you can clearly see the cartilaginous growth plates, the epiphyseal zones.
Yes, they're still actively expanding, totally distinct from the fused, solid bone structure you see in an adult.
Okay, from bones to how they connect. Arthrology, the joints.
Right, and the real workhorse of our musculoskeletal system is the synovial joint. It's basically a biological machine designed for complex, often high-friction movement.
And for that to work, it needs 3 fundamental components, right?
That's right. You need a joint cavity for space, an articular capsule to seal the whole thing, and synovial fluid, which is the lubricant and nutrient source.
Without that, it's just bone grinding on bone.
You'd grind down in no time. A synovial joint is essentially a sealed, self-lubricating shock absorber.
And the joint's architecture then dictates its movement. So let's talk about the axes of motion.
Okay, so you have the highly mobile multiaxial joints. The classic example is the ball and socket shoulder joint. It allows movement in multiple planes: flexion, extension, abduction, adduction, rotation.
It sacrifices a bit of stability for that incredible range of motion.
It does. Then, on the other end, you have monaxial joints, where movement is restricted to a single axis for strength and security.
Like the elbow.
Exactly. The hinge joint in your elbow, the humeral ulnar joint, is almost pure flexion and extension. And the pivot joint, like the radio-ulnar joint, specializes in rotation.
You know, what's fascinating here are the joints that are so critical for our evolution. The carpometacarpal joint of the thumb, it's a special type called a saddle joint.
And that wide mobility is what gives us our opposable thumbs. It's the core of our ability to grasp and manipulate things, a huge advantage that came with being bipedal.
And that grasp, requires powerful, precise movement, which brings us to myology, the muscular system.
And with muscles, form is fundamentally linked to function.
The atlas shows some of the different shapes. You have the classic spindle shape or fusiform, like the palmaris longus.
Right, which is designed for speed and range. But you also have multi-headed muscles, like bicipital or quadricipital, designed to distribute force over a wider area.
And then you have those feather-shaped ones.
The bipinnate muscles, like the tibialis anterior, they pack more fibers into a given space to maximize contractile force, even if it means a slightly smaller range of motion.
Okay, let's circle back to the visualization that makes this atlas so good for a modern learner. The integration of CT, X-ray, and MRI is just so important.
Absolutely, because those are the tools of clinical diagnosis. The atlas's comparative examples are indispensable. Think about the shoulder joint again.
Okay.
If a patient comes in with pain, an X-ray gives you immediate clarity on the dense structures. You see the head of the humerus, the scapula. You can spot a fracture.
But the X-ray is totally silent on the soft tissues, like the rotator cuff, which is so often the real source of the injury.
Exactly. So you compare that X-ray with an MRI scan, and bam, the soft tissues just spring into focus. The tendons, the articular cartilage, the muscles like the trapezius and supraspinatus.
So by putting these side by side with the photos, the atlas teaches you not just what the structures are, but how a clinician actually sees and interprets them.
It's teaching you to think like a clinician.
So if we step back and look at this entire deep dive, what's the core takeaway for someone learning anatomy?
I think the core insight is that the human body isn't a random collection of parts. It's a system, and it's grounded in these clear architectural rules: polarity, segmentation, and symmetry. The atlas forces you to move beyond just rote memorization by giving you photographic realism and clinical imaging, bridging that huge gap between a diagram and a real patient.
It turns anatomy from just a descriptive science into something more like a functional applied engineering discipline.
That's a great way to put it.
I find the author's admiration for the body in their preface so resonant. They talk about how precisely, beautifully, and admirably the human body is constructed. They even single out the hand, calling it one of the most admirable structures, and noting how its development after we stood upright allowed for complex grasping and even psychologic expression.
It's a masterpiece designed for both incredible strength and incredible subtlety.
It really is.
It is, and that understanding of architecture and function is central to clinical reasoning. So to reinforce what we've covered today, here's a short exercise for you, the listener. The shoulder joint is functionally crucial and structurally classified. Based on the mechanical structure discussed in this deep dive, which major joint type is the shoulder joint, and what specific characteristic allows its exceptionally wide range of movement? A little hint, think about the number of axes.